Okay, pulling together all of the things we know about factoring. Today we will be factoring completely. That means if one of your factors can be broken down further into factors, then it's not factored completely. So we want to keep going until we cannot break it down anymore. So first thing you want to check for is a greatest common factor. So when we look at number one, there's only two terms, but notice that they're both divisible by 3x. So we can factor out the 3x, which gives us x squared minus 100. And then hopefully we recognize that x squared minus 100 is the difference of squares. So remember our pattern. We know that the difference of squares can be factored. So I like to draw my parentheses because I know I'm going to break this up. And I also want to bring down that greatest common factor that we factored out first before I factor x squared minus 100. Since it's the difference of squares, we know that it will factor into a sum and difference of the square root of each term. So the square root of x squared is x, square root of 100 is 10. So that factors into x plus 10, x minus 10. Looking at number two, notice that all of those coefficients are divisible by 5. So first we factor out a 5. That gives us w squared minus 3w minus 4. Then I want to think about, can this trinomial be factored further? So notice the leading coefficient is 1. So those are the easy ones. So I'm going to ask myself what multiplies to negative 4 and adds to negative 3. And that would be negative 4 and plus 1. So since there is something that multiplies to negative 4 and adds to negative 3, I know it's factorable. So I set up my two sets of parentheses. We break up the w squared into w and w. And then our answer to what multiplies to negative 4 and adds to negative 3 goes directly into our factors. In number 3, all of those coefficients are divisible by 5, so we factor out the 5 first. And now I have a quadratic trinomial. The leading coefficient is not 1, so I'm going to multiply 2 times 7, which is 14, and put that at the top of the diamond. I just draw an x. And then our x coefficient is 15. We put that at the bottom. And then we ask ourselves what multiplies to 14 and adds to 15. That would be 1 and 14. So that just tells us how to split up the x term. So the 15x becomes 1x plus 14x, and then we factor by grouping. So I'm going to focus on just these first two terms and ask myself, what is their greatest common factor? That would be x. So I factor in x out of both of them. Then I look at the last two, 14x plus 7, and I ask myself, what's their greatest common factor? That would be 7. So I'm going to factor the 7 out of them. So then notice we did get 2x plus 1. That's going to be our first factor, the common binomial 2x plus 1. And then our greatest common factor is x plus 7. That becomes our second factor. And then also want to make sure we include that 5, that first factor that we factored out at the beginning. I ignored it for in the middle here when I'm trying to break down that trinomial, but just got to make sure we bring that back down and include it in our final answer. Looking at number 4, notice that each term has an a in it, so we factor out an a. So now we have a quadratic trinomial. Leading coefficient is 1, so those are the ones that are easy. So I know I'm going to split up the a squared into a and a. And then I ask myself, what multiplies to negative 84 and adds to 8? And that would be 14 and negative 6. I did use a calculator to help me find factors of 84 because I wasn't sure on the off the top of my head. So make sure you use that handy dandy tool when needed. Number 5, all of those terms are divisible by 2. So we're going to factor out a 2. And then we have 6x squared plus x minus 1. So the leading coefficient is not 1. So no shortcuts here. I'm going to take a times c. 6 times negative 1, which is negative 6. Put that at the top. There's an understood 1 in front of this x. So put 1 at the bottom. and ask myself what multiplies to negative 6 and adds to positive 1. And that would be 3 and negative 2. So that's how I split up the x term into plus 3x minus 2x, and then factor by grouping. Focus on these first two terms. Their greatest common factor would be 3x. So I factor out the 3x to get 2x plus 1. Then looking at the last two, this is a minus. So their only common factor is a 1, but since this is a minus sign, I'm going to factor out negative 1. So dividing both of those terms by negative 1, I get positive 2x plus 1. So the common binomial was 2x plus 1, and then our GCFs were 3x minus 1. Remember that we factored out a 2 at the beginning. I ignored it for a little while, but we got to make sure we bring that down and include it in our final answer. And lastly, number 6, all of those terms are divisible by 3. So we factor out the 3. I don't know what happened here. Factoring out the 3, we would get 5y squared minus 6y minus 8. Multiply 5 times negative 8 to get negative 40. Put that at the top of your x. At the bottom, we put the y coefficient, negative 6. And we ask ourselves what multiplies to negative 40 and adds to negative 6. So you can think about it for a little while. You can use a calculator to help you. But that would be negative 10 and positive 4, which tells us how to split up the y's. So I'm just kind of ignoring the 3 for a little bit while I focus on factoring this trinomial inside there. So we split up that linear term, then we factor by grouping. What's the greatest common factor between 5y squared minus 10y? That would be 5y. So if I divide both of those by 5y, I would get y minus 2. And we focus on the last two. Their greatest common factor is 4. So factor out the 4, and we get y minus 2. Y minus 2 is that common binomial, and then the 5y plus 4, our GCFs make up your second factor. And then we have to make sure we remember that 3 that we factored out at the beginning. We have to include that in our final answer. So that's the most common mistake with factoring completely. We might factor out a GCF first, but then we forget to include that in our final answer because we get distracted while breaking down that trinomial. Thanks for watching and taking notes.